Good morning, students. So today is the last lecture. So in the Google Classroom, it is recorded as lecture 47 and 48. So all the numbers have changed. So kindly refer. So it is 47 and 48. So in this last lecture, we'll see how to draw the ILD for shear force at a point. So the last lecture we saw how to draw the bending moment at a point, at D point. Similarly here, shear force at a point. And again they are telling us to compute the ordinates at 1 meter interval. So the ordinates are not given, the interval is not given. We can assume 1 meter or 2 meter or 1.5 meter. So that is left to us. So here it is given as 1 meter. So again see the diagram. It is a continuous beam ABC. So continuous over B, and A and C have roller supports. D is the midpoint of BC, whose span is 4 meters. So D is at 2 meters from B and C respectively, and the span of AB is also 4 meters. So diagram shows the shape of the ILD diagram. So if you see at D, you will have two values. So diagram shifts from negative to positive. So here you will have two values. So that you have to remember. And again we are going to apply Muller-Breslau principle. So difference in this problem is that because we have to draw the ILD for shear force, we will not introduce a hinge, we will introduce a sliding device at D which permits relative movement of two parts BD and DC. So if you introduce a sliding device at D, it permits the sliding or the relative movement of the parts BD and BC, and then we apply a pair of unit loads at D, so unit shear. So that is shown in the next diagram. If you see at D, there is a pair of unit load. One is acting upward, the other one is downward, one. So we apply a pair of unit loads. So again, to the formula for calculating the IL ordinates for shear force at D is yxt by ydt. So denominator will have only displacement because we are going to draw the ILD for shear force. So if you draw the ILD for shear force reaction, denominator will be only displacement. So again, the diagram, I am drawing a diagram again. So as in the previous problem, we'll solve this problem by using conjugate beam method. So conjugate beam method, first you have to find the reactions and then we'll draw the bending moment diagram. So bending moment M by EI is a conjugate beam, it's a load on the conjugate beam. So that is what we are going to do again. So this again similar to the last problem. So D point we have to draw the ILD for shear force. So D will segregate this part, we'll separate this part DC. So D to C. So let us find RC. So again at the D point, load is acting downward, 1. So if we apply summation V equal to 0, RC equal to 1. So RC is upward, whereas there is a downward load, unit load applied, unit shear applied. So now again we have to find MD, because when you permit the sliding of two parts, it will also have a moment. The moment represents the relative moment of the two parts. So that is MD here. So again let us find the moment at D or D2. So it will be RC into 2. So MD equal to 2. Now we have to find RB. To find RB, let us take the whole beam RA. So first initially let us assume RB as also acting downward. So RA, RB and RC acting upward. So we'll take the moment about A. So at A it is RB minus 4 RB is anti-clockwise. Again RC also anti-clockwise moment, minus 8 RC. So you get RB equal to minus 2. It means RB is not upward, it is acting downward. So again I change the diagram. I have crossed RB acting upward, I have marked it as downward. To find RA, let us apply summation V equal to 0, which is RA plus RC are acting upward, whereas RB is acting downward. So RA plus RC upward, which is equal to RB downward. So RA equal to 1. So once we find all the reactions, let us mark it on the diagram on the beam. So RA equal to 1. So moment at bending moment at any distance 1 will be RA into 1. So 1 into 1, so 1 by A. So 2 meter, 2 by EI, then 3 by A and 4 by M. And the advantage with this problem is that both RA and RC are equal to 1. So if you start from A till B, it will be 1 by EI, 2 by EI, 3 by EI. At 4 it is and at 4 meter is 4 by EI B. Similarly, as RC is also equal to 1, you'll get the same values. So this is the conjugate beam. So this is the conjugate beam. So the load on the conjugate beam is acting downward. Again we have to find the reactions RA dash and RC dash. As in the last problem, we are not concerned about B, because our concern is D, at which we applied unit shear or unit load. So again, no need to find RD dash, because we are applying unit shear and there is no support or hinge there. So you won't have any reaction there. You will only have a moment, which we'll find later. To find RA dash, let us take the moment about B. So this is also what we did in the last problem. We considered B. Though we are not interested in finding the reaction at B, we took this point of finding the other reactions, RA dash and RC dash, and as in the last problem. To find RA dash, let us take at the moment at B. So clockwise positive, anti-clockwise. So upward will have a clockwise moment, so plus 4 into RA, and the downward load will have anti-clockwise, minus half into, so till B. So load is area of the triangle into the distance of centroid. So at B is a straight edge, so the distance will be 4 by 3. So half into 4 by EI is the area of the triangle into 4 by 3. So using that you get RA dash is equal to 8 by 3 EI. To find RC dash, let us apply summation V equal to 0. So RA dash and RC dash are the upward loads. Total downward load is half into 8 into 4 by EI. So only the total load here. No need to find out the moment. Only when we took the moment about B, we had to multiply the load into distance of centroid. So this gives RC dash as 40 by 3 EI. So again, as I told you earlier, there is a moment mu, which represents the relative moment of the two parts, that we have to find out. Again, this moment mu at D is also the displacement at D. So that gives the denominator for formula. IL ordinates for shear force is D equal to Yx by Yd. So let us find mu in the diagram. So, and we'll only consider the portion BC or the right portion, because D is the right portion only. Again, taking moments about B, we get RC dash into 4, which is anti-clockwise. Again, mu is considered as positive. If we get a negative sign, we'll change it. And now mu we are marked as, so the mu we are marked as clockwise only. Again, the load half into area of the triangle, so half into 4 by EI into 4 by 3, so which gives mu equal to 128 by 3 EI. This is also equal to 42.667 by EI, which is equal to YD. Next, as in the previous problem, we'll start from portion AB and we'll start from A. So I have drawn the conjugate beam on the portion AB. At A, x equal to 0, so y0 will be YA, and at A, the bending moment equal to 0. So the bending moment in the conjugate beam equal to displacement y. So that is what we are doing here. So Yx in general will be RA dash into x minus half into x into corresponding m by a into x by 3. If you apply that till 3 meters, you get the values. So this you can do in calculator. For example, y1 equal to 8 by 3 minus 1 by 6. If you do it, you will get straight away 2.5. So now to simplify, you can just apply. Similarly, y2 is 8 into 2 is 16 by 3. 16 by 3 minus 4 by 3, you will get 4. So at B, x equal to 4. So y4 equal to bending moment 4, which is equal to 0. So A and B, the bending moment is 0. So y is also is equal to 0. So I have tabulated all the values right from x equal to 0 to 4 and the value of yd. So if you divide y by yd, you will get the values, and you can draw the diagram also. So A, it is 0, B also it is 0. At every 1 meter you can apply the value. As I told you, these are positive values, so positive values will mark it below the reference line. So you get this shape. Now portion BC will start from C. So at C, x equal to 0, so y equal to 0. Again yx, the formula is RC dash into x minus half into x into m by a into x by 3. So using this, if you apply for y1, you get 13.167 by EI. Now y2, you have to be careful at 2 meter, because 2 meter is D point. As I showed in the first diagram, it will have two values. one negative, one positive. You'll have two values. There's change of sign, so one positive and one negative value. So at 2 meters, y2, it is actually point D. You have to consider mu. First value to find without mu, and second with mu. So you'll have two different values. So without mu, it is again RC dash 40 by 3 EI into 2 minus half into at 2 meter. The value of 2 is the value of m by EI is 2 by EI. So half into 2 into 2 by EI into 2 by 3. So we get 25.333 by EI. And with mu, this value you have to just consider mu. So mu, so this bending moment, upward positive, downward negative. And this moment mu, it is a hogging moment. So this is due to a downward load. So hogging moment, so minus. So 25.333 minus 128.3. You'll get 17.333. So two values. So without mu it is positive, with mu it is negative. And then y3 also you have to consider mu, because you see here the diagram, from 0 to 1 you need not consider mu, but at 2 and beyond that 3 you have to consider mu. So the general formula, RC dash into 3 minus half into 3 by EI into 3 by 3, and then you have to include mu. As I told you earlier, it's a hogging moment, so negative sign you have to consider. You get y3 equal to minus 7.167, and yd is again x equal to 4 meter, and here the bending moment at B, sorry, it is not D, it is bending moment at B equal to 0. Bending moment at B equal to 0. So I have tabulated all the values. And every value if you divide by 42.667, you get the corresponding values. So 2 meter, you see one value is 0.594 positive, then it is minus 0.406. So positive value is 1, it is 0.308, and again 2 meter without mu it is 0.594. Then if you get negative values, you draw above the reference line. So that is what I had drawn. So this is a diagram, and then if you combine both these diagrams, you'll get this is the ILD for shear force at D. So this is the final answer. So here there is only one mistake. y4 meter is equal to bending moment B, that is 0. So that I'll correct in the lecture notes and give you in the Google Classroom. So kindly refer. So the test starts, the internal 5 starts from Monday, and Monday is my test. So I'll also post the formula sheet and revision for all these 6 problems. You have only 6 problems, and also I'll post the 2 marks. So do the test positively. Thank you.